So we're going to spend some time working through precipitate reactions. And just to remind you that precipitate reactions are double replacement reactions, and the key is that you have as a product a solid, usually from two aqueous solutions. All right. So this one follows a classic example of a precipitate reaction. You have two aqueous solutions, a formation of a solid or a precipitate occurs, and we're going to work that out. So to start off with any of these sort of equations, we first need to balance them. All right. And so we work on the potassium first. It looks like I have two potassiums that I need on this side. That allows two sets of NO3, so we have two sets here, one beryllium, and one sulfate. So it looks like just by putting that 2 there, it is balanced. All right, the next part that we're going to work on is the looking at what this actually means, okay? So we'll just identify our A's and B's. This here is going to be our A, okay? This one, anion, will be my B, plus this one here will be C, and this one will be D, reacting for this one to be C, combining with B, and A combining with D. So it follows our expected pattern of AB plus CD results in CB plus AD. So the next part, what we're going to do is we're going to start color coding these to see what they actually look like in a beaker. And I'm going to use the color red to symbolize my potassium. Well, give me a second here. Should work. There we go. So we have red being my potassiums. Okay. I'm going to have the color yellow be my sulfates. I'm going to have the color green be my bariums, my apologies, I keep on calling it. Oh, and we have a green one here. Okay, and lastly we'll have let's do blue as being our nitrate. Okay. So let's draw out what this looks like, and then start doing what we call our total ionic equation. So here is my beaker where I'm mixing these. On this side, I'm going to write total ionic equation. And we're more or less going to match our picture to our ionic equation. So let's start with our potassiums. It looks like I have 2 potassiums here. And I know I have 2 because of the subscript 2. So I'm going to draw 2 dots. And keep in mind that when ionic compounds are in water, they separate. We mentioned that in class, that ionic compounds always separate. So I'm going to write that down as being I have 2 Ks, and each of those has a plus charge. And that pretty much reflects what I see here in the picture. Okay? And in addition, let's do then our sulfates. It looks like I only have 1 sulfate, so I'm going to just draw 1 yellow dot. And sulfate is SO4 with a -2 charge. And I know that through by looking at the polyatomic chart. Okay? Then I'm going to add another plus. And keep in mind, the reason I'm separating these is that ions and water will separate. So I'm just showing what I have in this beaker. We're going to do green for barium. Barium, it looks like I only have one barium. So I'm going to just draw that one dot. And barium has a +2 charge. And then from the next one, the last one that I have are my nitrates. And it looks like I have 2 nitrates. I know I have 2 nitrates because of the subscript 2. So here's one nitrate and there's one nitrate, okay? So I would write that as a big 2 NO3. Each has a -1 charge. I know it has a -1 charge from the polyatomic chart. Okay. So next, what happens next? So next what happens is I'm going to look at that table that I gave you in class, okay? And if I look at that table, this is that sheet of paper, I'm going to notice that things that are soluble mean they're not going to make solids. Those that are insoluble will make solids. So I am going to check if any of these things can perhaps become solid. And I look and I say, oh, okay, I have a sulfate here. If I look at my table, it looks like it's in the insoluble compounds section. It should be insoluble, but when you look at the exceptions, you notice that if it's matched with barium, it should become a solid. So that's the one that's going to be a solid for sure. Now let me look at the next one, nitrates. If I look at my chart, I look for nitrates. They seem to be in the soluble compounds, and regardless what they combine with, they will always be soluble. There are no exceptions. So it's only this one that's going to be a solid. That means that our drawing is actually going to look like this. That, and I have the luxury of an eraser, that I actually have my barium, which is green, not being by itself anymore, and my sulfate, which is yellow, also not being by itself anymore, but they're actually going to combine. So that would look like a yellow combined with a green to make a solid, okay? So these here are my solids. In other words, my precipitate. So that's how they look in the beaker. So I need to reflect what my beaker shows. So I'm going to have the luxury of a black pen now. So it looks like I have one solid of BaSO4. Okay, and if you notice, the colors match. However, these did not become solid. They are still soluble. So I would write them still as is. I have 2 red ones, so I have 2 potassiums, and always include the charge, and I have 2 sodiums. 2 nitrates, which have a -1 charge. So this is my net ionic equation. This is what I see in the beaker. The next part is this is my total ionic equation. The next one is going to be writing my net ionic equation. And for this one, I just want to focus on what changed, okay? I'm going to ignore all the ones that did not change. So if I look at this, it looks like these all stayed the same. That means my potassium stayed the same, so I can cross those out. And my nitrates stayed the same, so I'm going to cross those out. The only thing that changed was that I had a sulfate and a barium that were separated. When they were mixed together, they formed a solid. So I'm going to have my net ionic equation only show that change. So my net ionic equation would look like this. Okay, and we are now finished. So we're going to try going through one more where you're actually working on it on your own. So I'm going to pause for 1 second, and then we'll get back on the screen. All right, so let's try another one. So here I have barium chloride with sulfuric acid. So the first thing I want you to do is I'd like you to write out what your products are going to be. So what is this area going to look like right here? So I'm going to stop for a second. If you could please pause the recording and try it out, and I will then work you through it with you again. So if you can pause now. All right, so what you should have is products that look like this. We have barium sulfate and hydrochloric acid. Hopefully all of you took also the time to figure out that, which one of these is going to be a precipitate, and you notice that sulfates from your charts, if you take a look at a sulfate, it's soluble except for when it bonds with barium. So this would be a solid, okay? So you would expect that to be the precipitate. So again, what we're going to do is, this time I'm not going to do the A, B, C, and D, but instead I'm going to just draw these out. We're going to have our beaker here. We're going to do our color coding, and we're going to have barium be red. We're going to have our chlorine be yellow. And next we're going to have our hydrogen, remember that's in cation, be green. And our sulfate be blue. Okay, so what I'd like you to do right now is you're going to draw what that's going to look like in the beaker, okay? And go ahead and pause, draw it of what it would look like in the beaker, and we'll start by doing our total ionic reaction then. All right, so you should have something, and if I look here, I noticed that I did not balance my chemical equation yet, which simply by placing a 2 here should do the trick. So that was the first thing I needed to do. Looking at that, it looks like I have 2 sulfates in there. My apologies, I only have 1, so I should erase that. There we go. I have 1 sulfate that went in. I have 2 hydrogens. I know I have 2 hydrogens because of that subscript 2. 1, 2. I have also, let's get in there. I have, and I don't want blue. I have 2 chlorines. So I do 2 yellow dots. I know that because of my subscript 2. And I have 1 barium. Okay, so here are my ions that are in there. And I'm going to write that out in black. So my total ionic equation should look like this. I have 1 barium. I don't need to have that 1 there. That has a +2 charge, plus 2 chlorines. If you take a look, I have those 2 yellow ones. Plus 2 hydrogens, which both have a +1 charge, plus 1 sulfate, which has a -2 charge. Okay? And we now know that they are going to make a solid, that barium SO4 is going to be our solid. So these 2 will combine together, leaving still 2 chlorines and 2 hydrogens. Okay? So we're going to cross out the ones that were not affected to give us our net ionic equation. And I need to talk fast because I'm going to stop my recording, of being Ba plus 2 plus SO4 minus 2, forming to make BaSO4. Okay? And that would be your ionic equation. So there's one example yet again. So I'm going to have you practice some of these for homework, and then we'll go through them in class.